Hello, my name is Hector Vladimir. Today is the 8th of November 2024, and I am going to discuss the 5 hazards of human spaceflight. These are NASA's 5 hazards of human spaceflight. I'm going to be discussing quickly and briefly these 5 fascinating, puzzling, and challenging hazards that pose problems to missions to outer space, missions to the moon, Mars, and other celestial bodies within the solar system. These 5 hazards are unsolved problems that we are yet to conquer. We are yet to fully satisfy and fully put behind us, develop, protect against. These are problems that are not fully studied, satisfactorily known by experts to the extent that we are comfortable in solving their problems, solving their harms, their hazards posed to the human body, let alone the technologies that will be needed to mitigate these hazards and the effects of these hazards. Those technologies are still in testing laboratories, they are still in development, they are still in their planning stages. Sometimes they're still just hypothetical conjectures, sometimes they are just being studied on paper, on computers, and some of them have no mitigating technology that is developed. Of course, there are many technologies and techniques that have been developed over the years, over the many decades that we have been flying to space, to the moon, and to low Earth orbit. Of course, these things are things that are being done. However, these 5 hazards remain problems for human spaceflight. NASA and other space agencies are actively researching them, studying them, and looking for solutions and testing the technologies that do exist that are being built and put to test. These are actively being tested and tried out to see how they work out in space. Some of them have flown to space and have been tested in space, especially during the Apollo missions and during the many International Space Station missions. However, these remain technologies that have been untested for deep space flight, that is, to flights beyond the moon. So the first hazard that I'd like to discuss today is radiation. Radiation is believed to be the most severe of the 5 hazards, the one that is the most challenging, and radiation is extremely debilitating for astronauts taking part of missions to, again, deep space. When I say deep space, I mean trips to places above low Earth orbit. Low Earth orbit is the orbit that the International Space Station currently flies around the Earth, which is no more than a few hundred miles above the surface of the Earth. So radiation is extremely hazardous and extremely debilitating again to the human body. It is estimated that on a trip to Mars, which by the way would take several months to over a year to complete round trip, sometimes estimated to be over 2 years, you will be exposed to radiation levels 60 times more or higher than a person that remains here on Earth during a working career. On a trip to Mars, you are also estimated to be exposed to radiation levels that equal hundreds of times the amount of radiation given by X-rays. For example, chest X-rays. It is said that you may be exposed to up to 600 chest X-rays in one Mars mission. So the ionizing radiation, those are the very fast flying high energy particles that are constantly raining down to us from space. Here on Earth, we are relatively protected from these cosmic radiation high energy particles and rays that rain down at very high speeds, sometimes approaching the speed of light. And these are heavy elements. Elements like uranium, gold, silver, iron, very heavy elements, and they are in their atomic composition at their atomic level. Only the atom remains from them, so of course they're going to be microscopic to where they're not detectable. However, they are still there, real, and they are raining down on us. And we are protected here on the Earth because of the Earth's protective magnetic field, which is huge, covering miles into the sky, and these particles are deflected by this magnetic field. Of course, other planets have such magnetic field, but not Mars and not the Moon, which are the 2 celestial bodies that we plan to visit, colonize, orbit, whatever the case may be. Also, the area called the Van Allen belt around the Earth are areas of the Earth which are extremely hazardous because they have trapped radiation from space flying all around it. Thus, as we fly through this area of the magnetic field of the Earth, we are exposed to very high doses of radiation. So flying fast through this area is extremely important and crucial. Also, the space between the bodies which we will travel to when we go to missions such as moon missions and Mars, the space between those, the Earth and those, is vast, especially for Mars. I believe it is over 140 million miles, the average distance from Earth to Mars. So the distance is many times that of the moon and Earth. So astronauts, people that take part of such mission to Mars, will be exposed to extreme amounts of radiation. Of course, through the trip there, radiation also originates in the sun. The sun emits high doses of radiation in the form of solar wind and coronal mass ejections. So solar storms, they call sometimes. These are very high speed, highly charged, highly energetic particles from the sun that erupt in many cases. The solar wind is always there, the radiation from the sun is always there, but at times there are heavy amounts of this radiation that is highly concentrated, called solar storms or coronal mass ejections. One solution for the radiation is ship shielding or spacecraft shielding. Many materials have been developed, studied, tried to see what materials can shield from radiation better. One of them that has been found to shield from radiation is water. Another is human waste. Another is lead, the metal. And there are many others. I believe hydrogen is one element that is very efficient or effective in deflecting radiation. That is why water is a very good radiation blocker or filter. But water is very heavy. The same goes for lead and other that may be good filters or good shields for radiation. But the space agencies are working hard on developing and finding out and studying these and any other materials, including composites, that may serve as future shields that could be incorporated into the frame for spacecraft. Another solution, possible solution for radiation, may be drugs. There may be already drugs that are being tested that are anti-radiation. I believe there are some that have been tested before that may alleviate the symptoms of radiation, that may even prevent some radiation health problems.
While there are currently no FDA-approved anti-radiation drugs specifically designed for astronauts to take during space missions, researchers are actively investigating potential medications and dietary supplements that could act as radioprotectants, including antioxidants like vitamin C and A, certain types of fiber, and drugs like metformin, a diabetes medication which may help mitigate the effects of radiation exposure in space. However, further research is needed to determine their efficacy and safety in the complex space radiation environment.
Also, genetics in the form of crew selection, by selecting people with less susceptible genes to radiation caused health effects or problems, such as people with very low susceptibility to most forms of cancer. There may be people that are highly resistant to radiation exposure, so those people may be tested and analyzed genetically so they can be part of crews that go to these deep space missions. Another solution may be to find a way to go to and fro these heavenly bodies faster travel times, trip times. That lessens the exposure, shortens the exposure to radiation, therefore lessening the effects of radiation on the body. So for that, we would need faster spacecraft, more powerful and more efficient propulsion, which may or may not be on the drawing boards for the space agencies. There are many propositions for other types of propulsion other than fuel rocket-powered propulsion, and I'll leave that at that. Gravity fields. Gravity fields are a huge challenge, an unsolved challenge at that, for deep space human flight. That is because the changes in the gravity on trips beyond the moon are quite severe, and they have very debilitating effects on the human body. First, you have to take and absorb the stresses, the biological stresses of breaking away from Earth's gravity. The body is finally attuned and accustomed to Earth gravity. It has evolved to acutely be attuned and be healthy on Earth in 1G exclusively. Anything more or less will have a adverse effect on the body. That is just hands down
the case in fact.
And of course, as I mentioned, you have to absorb the stresses
On the
body breaking away from Earth's gravity, which is, as of right now, quite a stressful experience for the body. You have to
endure
several G's of force, perhaps approaching
3
G's of force at launch, and then once you break away from the Earth's gravitational field, which doesn't take long, I believe maybe a few minutes at current speeds of rocket power, then you will immediately feel the weightlessness of low gravity or microgravity just outside of Earth's gravity pool, which you will feel floating, as many of you may know, and this will immediately begin to work on your body in a negative manner, adversely. This will begin to affect your body adversely immediately when you begin to feel weightlessness. You begin to lose bone mass as well as muscle mass, and your internal vital organs begin to suffer from the first moment of lower gravity than 1G. Specifically your heart, your nervous system or brain, and perhaps many other vital organs such as kidneys, eyes, lungs, liver, who knows what else. Also, it has been found out that you lose about
1 to 2%
of muscle and bone mass, I believe. Close to
1 to 2%
muscle and bone mass is lost per month on microgravity or zero gravity. Also, the changing gravity fields will bring additional stress to your body. Biologically, you will suffer as gravity fields change from zero to the gravity of the body where you will be spending some time, such as the moon or Mars, which do have a lower yet a significant gravity field. I believe Mars has close to a third of Earth's gravity field, so it will be on about a third of the gravity that you do usually feel here on Earth on Mars. That will definitely affect your body, and you will have to quickly adapt to that, and that will also take a toll on your overall health. Some known and proposed solutions to this very large problem of changing gravity fields is exercise. Heavy and strict exercise regimes need to be closely adhered to, or else suffer the consequences. I'm talking about over 2 hours per day on a daily basis on a long duration trip, and I am talking long duration over a couple of weeks of being in minimal or zero gravity, and even that very strict and hard to adhere to regime of exercise will not do a whole lot to keep you fit, to keep you healthy. You will still feel the ill effects of gravity on the body. You will still lose bone mass and muscle mass, and will suffer with your cardiovascular and other systems. Another solution is artificial gravity. Many systems have been tested to attempt to generate some sort of artificial gravity. There are still technical problems to be worked out with those systems. They have local systems that basically spin you for a certain amount of time every day, and that combined with some exercise may lower the effects of low gravity on your body. However, those systems have major unsolved problems to be worked out, if they can even be worked out. One of them being, I believe, vertigo and motion sickness, so the body does not react well to a spinning motion. Your eyes, your inner ear will feel the motion, and this, of course, is an unnatural state that your body will attempt to reject and adjust to, will get confused because it is just not evolved, made to be in such a situation. Crew selection could be a alleviating factor there. People that are more resilient to low gravity perhaps could be chosen to go on these missions. People that could adjust a lot easier to changing gravity fields could be selected for these trips. And also, trip time could be shortened by better, more powerful, and more efficient propulsion technology. Of course, shortening the time of travel, therefore your exposure. shortening the exposure to low gravity or no gravity. Isolation. The problem of isolation is quite severe. It means that it affects the crew, it affects mission readiness, it adds complexity to the mission, it by design adds complexity to the technologies used. The spacecraft and all of its systems need to be more redundant, they need to be magnitudes more reliable because of the isolation, basically the separation from Earth, the sheer distance from Earth. And again, this is on deep space flights or travels, trips, missions beyond the moon. There are psychological challenges, stress, the lack of socialization with family and loved ones. Yes, there are communication methods to speak with family and friends from the spacecraft. However, as you go farther and farther from the Earth, there is a communications delay, a lag that could be several minutes. For example, a trip to Mars. As you approach Mars, the communication lag could be nearing 20 minutes. So that could be quite inconvenient, unnerving, and it could affect people, their mood, level of stress, etc. The isolation also affects your performance, since you will be under a much higher stress level. Your performance, physical, biological performance, and also mental, cognitive performance could decrease. You may lose focus, the stress and thinking about your isolation or realizing your isolation from Earth could affect your mood again, your performance level, and even your health. You may become anxious, depressed even, and that could definitely affect your health, mental health especially. Mars is a very long way from Earth. The Earth will be lost in the background. It will appear as a tiny dot in the distance. That could affect your attitude, your mood, your performance again, your mental health. It could affect your morale. And you may start to think things that you may have not thought before, perhaps about your past, your family, your deeds, shortcomings, and that may affect your performance. There are many techniques, methods to combat these effects of isolation, of course. Activity, work, exercise, socialization or socializing events, and activities with the crew, what I call the crew life. Basically, be attached to the crew and be comfortable and friendly with your crew or team members or astronaut group, that you are busy enough, happy enough, and satisfied enough with your environment's immediate company that the effects of isolation are minimized. Also, ship design such as lighting, colors, the size of the living quarters, cabin, food even, could improve the problems of isolation, especially the psychological problems of isolation. And also the selection of the crew is highly important. I would think selection of a crew that is very tightly bound and very comfortable with each other would be highly important and advantageous. And also cutting the trip time to minimize the effects of isolation would also help. Again, by this I mean using the technology that could get you there as fast as possible. On that note, distance from Earth is the fourth hazard or problem that we have not solved in going to long duration space missions. That is one of the hardest things to change about human spaceflight. Distance from Earth is unchanging. Anything short of warp drive or wormholes, which are just theoretical conjectures, anything short of those, the distance from Earth to other celestial bodies will be unchanging. A trip to a nearby planet such as Mars is vast. The distances are unimaginably great. One can only appreciate that once one experiences travel across such a distance. If you've ever been on a long flight, you can get a small, tiny taste of this. If you've ever been on a long trip in a bus or train, you can appreciate what a long trip feels like, and you can probably begin to imagine a multiple month to over a year trip each way would feel like going to a place like Mars. Distance from Earth is a very great challenge, one that has not been solved as far as what we will do to alleviate the effects of such problems. Psychological health problems, problems with the crew, problems with the supplies, problems with the trip time again, the technology to be used, the propulsion system to get us there and back are only now emerging. They have not worked out all the kinks from those technologies just yet. We yet are to come up with a ship that is capable of going to Mars and back. Believe it or not, we do not have that technology built. A trip to Mars would require most likely multiple ships and using propulsion systems that are yet to be built. So that makes it a problem that has been unsolved to this day. Also, the communications lag is a problem that has a lot to do, mostly to do with the distance from Earth. That means that the mission design will be magnitudes more complex because there needs to be a certain level of autonomy with the crew, with the technologies, and much more preparation is required because the crew and the ship will be expected or will have to react on its own to problems, to malfunctions, to any issues that may arise because of that communications delay where you cannot depend much on support or help from flight control or space flight control back on Earth. Lastly, the hazard of closed and hostile environments. These environments are not only limited to the spacecraft or cabin within the spacecraft, but they extend to the celestial body or planet or moon where the crew goes. Of course, the ship itself will most likely be a small living quarter. Ships cannot be extravagantly big because of technology limitations, funding limitations, etc. And also current propulsion system limits the size of a ship. So the living quarters, the space where astronauts will spend most of their time, will be limited in size. Of course, that will feel cramped, that will feel relatively small for them in comparison with the living spaces here on Earth. And that again will affect not only psychological health, mental health, but also biological health, your overall health, because there is more susceptibility, more chance for germs to be spread among astronauts or humans, people. There's more chance for disease and transmittable diseases to be shared between the crew. Germs may change and evolve more rapidly in space, according to what we have found. And diseases may mutate and evolve to forms that our body cannot fight. And even friendly bacteria, organisms that live in our bodies that are beneficial or neutral in Earth's gravity, they may evolve to something that may harm our bodies in space. This is something that NASA is diligently studying and attempting to learn about and come up with solutions, and it remains an unsolved problem for human spaceflight. There are many human traits and factors that affect people and potential crews on missions to the moon and beyond. Problems between crew members related to politics, religion, race, hierarchy are issues that remain unsolved. We are very often beings that resort to aggression, conflict, even violence and hostility when problems and disputes arise, when heated disagreements arise, and that is something very hard to avoid because it is so ingrained in our nature. It is very hard to find people and to train people away from those feelings, those reactions, which again may be tampered on Earth, but when exposed to all of the other hazards and all of the other challenges in space may sprout, may arise suddenly, or may be magnified. Sexual tensions may also become a challenge or problem in space. Competition for partners, for potential mates, may on Earth, disputes, betrayals, all kinds of